Hello and welcome back to another Island 54 development stream. So yesterday I kind of mainly just getting back into things, getting my development environment up and running again, and then I put a bit of work into improving the performance, well, measuring the performance and then improving the performance of the server. Today I'm going to continue work on that. First of all, just going to rename this sketchpad over here if I can do it. Add a new one. I'll just keep a little bit of a to-do list somewhere in here. So I managed to get the terrain service scaling. We definitely need to do this, which is when the terrain service does a graph build to do some pathing, we need to actually cache that. Now, whether or not I'll get to this today, I'm not sure. Because at the moment, it's building this graph every single time it tries to do any pathing, and that's a huge load on the terrain service. There's another thing in here, which is that the AI is calling the pathing endpoint for every single tick. AI should not call pathing service on every tick. It should instead be caching some of its results. And then if it can see that what it's got cached seems to be pretty good, in other words, the target it's moving towards is in roughly the same location it was before, then there is no need for it to recall that endpoint. What else have we got? So I've lost my window. There it is. Enumerating agent seems to be slow also. I'm not sure that's actually true. Agro AI is too slow, taking 100 milliseconds per entity per tick. That's covered by these other issues. Delete that one. I think that my delete endpoint on the entity service is still broken. I do still need to, well, what I'm going to do here is this one I'm going to call the performance issues. I'll create a new to-do list in here, which is just going to be the bug backlog. The client does show a lot of player capsules. Okay, and then we need to implement some sort of fan out mechanism. So this is where I left off at the end of yesterday, is I was looking at, we had just made it so that the terrain service could be scaled. It spins up like 10 instances or something. That kind of works around these issues here by just having extra instances running in parallel. The other thing we need to do is scale the UDP transmitter service. This is the more interesting piece of work that I'd like to focus on today. In order to do that, I need to do two things. One is allow multiple UDP transmitter instances. And I'll explain that in a moment. The other is to implement fan out for session enumeration. And I'll also explain that in a moment. Multiple UDP transmitters. So for anyone wondering about this tool, this is a tool that it's written by a friend of mine, and I'm trying it out in anger just to try and get some feedback for this friend of mine. It's quite an interesting idea. I think that you can sign up. If he's in the chat, might be able to type up and say whether or not that's a good or a bad idea. But it's kind of a nice way of keeping notes, diagrams, things like that. So why is multiple UDP transmitters hard? Well, one is that at the moment, the network mode for my UDP transmitters is set to host. Now, that means that when a process on the Docker container opens a port, it's actually opening it directly on the host, not in the container itself. And that means that I can't have multiple, or I can't meaningfully have multiple instances of this service because they'd all be sharing the same port, and I'm not sure what the implications of that would be. I assume it would just reject the attempt to create them. The other issue is, well, I think that's the main one. Oh no, we also need some sort of need a way of sharing a host network port. Now, the issue here is the client is connecting to localhost port, I don't know, it's 1554 something or other. And if I have multiple instances, we need a process of some sort actually just listening to those UDP packets coming in and sending them out to the back end, out to multiple instances of the actual UDP receiver. In fact, that's the UDP receiver side of things. Right, I'm going to take a step back here and say, no, that's not true, because I'm trying to do the UDP transmitter. If I have multiple instances of this, as long as they can send UDP packets from the same source port, I'm absolutely fine. So network mode, the question is, how can I get UDP packets sent from multiple containers, the same source port? Okay, so that's what I'm going to focus on now. That's the very first bit. Fan out for session enumeration, I'll go into more detail later in this stream, assuming I get through this stuff. And this is about if I have 1,000 sessions established, so 1,000 clients connected, and I have 2 instances of the UDP transmitter, I need each of those instances to process half of the sessions, or approximately half of the sessions. And there are a number of different strategies for implementing that. But yeah, we don't want each of the instances to process all 1,000, which is how they behave at the moment. Now, what have we got here? Let's start with the UDP transmitter service. I did try spinning this up to 5 instances, set that to 2, try running this. Oh, something wrong with my IntelliJ setup. It does come good once I've done a build, I think, outside. Oh, that's not good enough. Okay, we appear to have 2 instances of the UDP transmitter. See, one of them here and one of them here. And they do seem to have both come up. That's a good sign. Now, what happens if we connect a client to it? Can they both send packets? I mean, we'll be sending duplicate packets here because each of those instances will now be generating packets on every tick for this one client. But if it's able to do this, then the whole network mode thing might be a bit of a red herring. Taking a while. Now, it's worth noting while this is spinning up that this fan out thing I keep on talking about is also going to apply for the ticker service, because when we're processing AI and things, if we've got multiple instances of the ticker service, we want those AI agents to get distributed between the various instances of the ticker. But whatever mechanism we use here is going to get reused really heavily in the back-end infrastructure. All right, so we connect a client. Connection refused. Um, 15541. Right, this unfortunately doesn't give us back reason for the failure. We create a new scratchpad here. Play some feedback. Failed HTTP requests. Pass that on to the author of this tool. So I'll do that from the command line. Seems to be working. This isn't what I expected to be working on. that down, see if we can bring it up in here. No, it's really not letting us, is it? Okay, so IntelliJ seems to be refusing to run it because string, not a valid int. I think IntelliJ is unfortunately trying to interpret this file. And it doesn't like my port ranges. I wonder if there's another way of specifying a port range that won't annoy IntelliJ. Let's just have a look at the documentation there. Those ports. Okay, hold on. I see what's happening here. We've actually got two issues here. We need to expose the terrain service to the host so that the host can download chunks of terrain, and it's expecting it to be on port 15543. The problem is, yeah, I think that I can work around this just by telling the client just to connect to this port here instead of 15543. I think that will work. Let's give that a try. That's not what I meant to do. My OBS, that probably led to all sorts of nested stuff. Okay. Oh, well, he's rider. Know how to connect to the terrain service. It'll take me a moment to find. Okay, terrain here. There it is. Terrain service base URL should come from the session manager. And the reason for this to do is as these ports change, it should be up to the session manager to know how the client is meant to be connecting to the server. So let's put that in there and why this is duplicated, but one's loading the mesh, the other one's loading the actual height map. I'm not sure the client uses the height map anymore. An interesting little fact. Okay, so now when I rerun this, I think I'm running from the command line. I really don't like the client having to connect to specific ports. I think that what I'm going to have to do is sooner rather than later, in fact, maybe even today, actually have like an Nginx process running somewhere that's that receives all these requests and then dishes them out in the back end to the appropriate backend service. It's fine from a scalability point of view because that'll get replaced by an elastic load balancer when this is running in AWS. All right, so this has failed. Why? Simulate one of these. Something like that. Oh, it's going to be loading chunk 0, 0. Empty reply from server. That is definitely not what I expected. What's this? Oh. Really don't know what that is. Where my terrain services are. I do have lots of terrain services sitting there. Regular expression for terrain dot star listening is what I'm after here. Oh, of course, it thinks it's listening on 15543 anyway. All right. So I need to know which port that's mapped to. Uh, so here's one of my terrain services. Let's just take this one. It is listening on port 15660. Okay, here's the issue. Here's why this approach isn't working of updating the client. The problem is that Docker is just choosing a random port from within the range I've given it. Welcome back, Metalstorm. Good to see you again. Yeah, it has been a while. I started streaming again yesterday, and at the moment I am focusing on kind of proving the scalability of the server infrastructure. Because there are a few rough edges that I really glossed over, and the whole point of what I've done on the server is to show that this stuff is arbitrarily scalable. So that's what I'm focusing on right at the moment. Fighting with Docker at the moment. So yes, I cannot connect directly to these services because I don't know which ports Docker is going to assign. So let's come back to my little to-do document. And I'm going to count this as a performance issue. Implement Nginx aggregator. Now, I don't think this will be too difficult to do. So what this is going to be is it's going to be just an HTTP server that's able to receive requests, look at the first little bit of the request, like the path, work out which service it's meant to go out to, and then send that through. And so this is like a load balancer in Amazon. And this should be really straightforward, I think. I remember my Nginx format, my Nginx syntax, and can work out how to get it to read the data out of Docker. Should be plugins and things for that. That should be really straightforward. Docker pose Nginx scale example. Don't want to scale Nginx itself. Close to what I want, but I'd rather have this bit in here be completely dynamic. Okay, so this person looks like they have a working configuration just with a silly little typo in it. All right. Docker compose. Now the good thing is a lot of this port configuration will go away under this scheme. I will just call this one API. It's like the API endpoint. I don't think this is right. I think that we actually want to say image or something. Yep. Service. Yep. Image. They specify a version. I guess I should do that, shouldn't I? Oh, it's not going to let me do it. Docker Nginx. Let's pick 1.23 to make sense. We need a port mapping. I'm going to put this on 15540. That port used elsewhere. That's not being used. Oh, yeah, kind of. The UDP receiver is using that port. Do that for now. They then mount a volume. I believe this is where their bug is. Fix that in a moment. Oh, I see their bug already. Is they mount the configuration file. And this is going to have a really complicated depends on clause, but I will leave that for now. Nginx. Then we'll grab their Nginx file. Nginx.conf. I mean, better than this might be to actually put a Docker file up in here or something so that stuff is just all centralized, but I don't think it matters too much. We do that. Plugin, let's install a plugin. Welcome, random guy. Just fighting with Docker at the moment. I don't want to buy the plugin. Okay. Okay, so someone comes to chunks. Then we are going to go to terrain / chunks. And in here, we can go find the name of this. It's services terrain underscore dash services terrain 1. Colon 15543. Now, if this works, of course, I'll be able to put these onto a a simpler port rather than trying to keep track of which ports are which. Okay. So back in here, 15543. I can comment this out because we no longer need to map these ports onto the host. I very much doubt this is going to work first go. Bonus points if anyone can spot in advance what's going to go wrong. Docker compose build. I think this will fail. No, that worked. Wow. Up. Take a moment for it to download the OS for the API server. There we go. That's not empty. Attempt to perform migration. Launching. Host not found in upstream. Ah, yes. This is just a bit silly. This might actually all just magically work the way that Docker works under the covers. I think we actually just put terrain there. Docker sets up a fake DNS server that's able to resolve a service name to an IP address, a virtual IP address on the Docker network. But I believe that what actually happens is if you have multiple instances, it sends back multiple IP addresses. So I think this should just automatically balance, which would be nice. The other thing is, have I just fixed my IntelliJ configuration? I have, that's good. So I can now run from inside IntelliJ. Yep, UDP transmitter is unhappy. This doesn't surprise me. It's trying to rebind an address that's already in use, so I need to sort that out. Okay. It's my API configuration. So I should be able to hit up that port and get an error message or something, right? So if I go localhost : not that one, 15400 was it? 500. No. It's a bit surprising. Connection refused. API service. I'd say it's crashed. All right. Can I pull up the logs for it or something? Docker containers. No, services. API log. Host not found in upstream. Okay, what are these guys doing? They've got an Nginx server on what, 42,080. They've got a database backend and a PHP front end. Then whenever anyone goes to a PHP file, no, whenever anyone goes to slash, sorry, it's going to load. Not sure how this is working. API. Okay. So it's trying to hand it off to port 9000 on this service, which I really don't expect to work because that's the same mistake I made the first time. Oh, I need the depends on. It's a bit frustrating. Depends on. How do I write a depends on clause? Need service healthy. I need terrain. It's not right. Terrain. Addition service healthy. Yeah, so I think that because it hadn't even attempted to spin up the terrain service yet, the DNS call was failing when it did that. Next, what happened? Rerun that. I probably could have at least tested the system by just restarting that one part. It was just restarting the API service. It's the API. Is it even trying to restart the API service? See it. Okay, this is getting further. Server directive is not allowed in here. That's just going to be um, this in an HTTP text. Have stream going to be terrain in this case. Yes, the lag just got me there ahead of you there, Middlestorm. But I'm surprised that that gives us that error. Start. Server directive is still not allowed. Okay. Say this is just a version or something. First see this. Um, uh, I must be missing part of the configuration here. Oh, yeah. This I think this is meant to just sit inside this block. I think that's better. I'm I'm moments ahead of you, Metalstorm. Okay. This is what happens if you copy code off um, Stack Overflow questions, where the problem is actually just the person having lots of typos in their code. Okay, try it again. Aha, that looks better. That looks much better. So back over here. Oh no, I need my browser. And what happens if I hit up this endpoint? Excellent. And if I do slash chunks 00, excellent. That is working. Uh, okay. So what I can do now, this isn't really necessary, but it's going to simplify things a bit. I'm going to get rid of these silly port numbers. So I'm just going to use 8080 as my default port. And then over in the terrain config.yaml, we'll run this on port 8080. Anyone referring to 15543 now? The external URL for the terrain manager is now 15500. We no longer need to do any port mappings on the terrain service itself. This should be port 8080. Excellent. Let's bring this down, Docker compose down. Docker compose build, just to make sure everything's up to date. Run this. Then in the client, 1544, no, two spots where I refer to this. Oh, 15500. Again, I'll get rid of this once, or I'll set this to something that looks a bit more like Island. It was always the 154, something like that. That was the joke about these port numbers. This one to a 5. Okay. So the server is running. I should be able to connect client. Oh, this one thinks it's already connected. Yes, let's just stop that before it makes a mess. Hit play. Hopefully it can find the chunks. Yes, it found the chunks. Still got these weird capsules appearing everywhere. That's all right. I'll load in a troll. Oh, it didn't like that. Very much didn't like that. Ah, I know what that will be. That endpoint, this prefab endpoint, it takes a coordinate, but you'll notice this is only the hexagonal coordinate. We don't give it the height. And what it does behind the scenes is it goes off and asks the terrain service where it should put the troll. So one of the downsides of these microservice architectures is when you make large structural changes like I'm making at the moment, you often need to update things in a lot of different places. Everything depends on everything. The advantage is when you're making small changes, you can make them independently. The systems don't generally need to know about each other than the API. So the question is, why something's still trying to hit up the old service? Sneeze, excuse me. Okay. So yeah, anytime I see this, this needs to be, okay, whenever it's an internal one, we now use terrain 8080. 8080. So this is bypassing the Nginx server, worth noting. I'll need to set up pathing. Let's just get a note of that. Okay. This is a local doc. Not sure that actually gets used, but fine. Brainport is I'm really sure that doesn't get used. It'll fail if it does, and it should be using a configuration file of some sort anyway. Brain service is 8080. This is the directory service, so this is how the client should be accessing this, accessing the terrain service. Okay, so I need to set up the pathing in the Nginx server. It's doing, there we go. I think I can just do this as a second one of these. Now this should not work if I go /path, get a not found, but if I now restart the API service, restarted. Oh, there we go. That's just restarted. Invalid location modifier /chunks. I don't know. I presume this is a regular expression or something, is it? I do that. Otherwise, I'll just have to do a second location block. That appeared to work. No. Right. Nginx location directive. Samples, that's good. Ah, okay. So I think I need to do tilde. I think that will do it. I'll just look at what those modifiers can be. There was a caret tilde as well. Caret tilde, the caret followed by tilde. Longest requested URI. Oh, yeah, of course. I'm sure there's a better way of doing it than this. I kind of want to extract, if it's chunks or path, I want to extract it and extract that component and send it through on the end of here, but this will work. It's a simple enough case. I assume I'm allowed multiple location blocks, otherwise I'm in trouble. Ready for startup. Does that mean it started? Or gets the path, that's at least coming from the correct location. Chunks. Yeah. /44. Go. Yeah, I can't. I just need to make sure that the path endpoint is actually /path. Paths. Path controller comes from path route. Which I don't know. Paths /paths. Okay. Okay. So I am pretty sure that's right. Everything will fall over. If it isn't, I do need to restart that service. Then I should be able to run this. I should be able to spawn a troll in. Yep, we got a troll, and the troll should be able to pathfind. So yeah, here we go. It's a bit slow, but sorts of stuff changing in around there. Okay, that was pretty cool. Now, when that troll was pathfinding, let's actually get an example here. Gonna get some noise in a second. Oh, no noise, excellent. While he is pathfinding, I want to see that the requests are actually getting distributed out to the multiple backends. And they do not appear to be, unfortunately. Hit my sound. So it seems to be always going out to terrain 6. So I need to work out how to get Nginx to properly distribute those. Really surprises me that that didn't work straight out. Nginx. Upstream, multiple servers, same name. Isn't quite what I want. Yep, so this is exactly the situation I have. Docker. All right, so I've got 2 servers running. Still not quite what I want. They have an example where they actually scale it. I mean, maybe I should actually confirm this is a real issue. There we go. it is in fact always, oh, there we go, it's passing out to server number 8. Right, it goes out to 8 for a bit. Disconnect, reconnect. Yep, it's gone out to server 2. It seems to be doing some sort of intelligent load balancing, in fact. Oh, let's spin up some more trolls. Find my command line. Another troll in there. Terrain 9, you can see these requests going out to the same server. Terrain 5. Yeah, okay. It appears to be actually load balancing. Really good. Nginx aggregator. Well, I guess it is time to start bringing some more stuff across. Welcome back, Random Guy. I have this Nginx aggregator is successfully working. Very good news. This is going to make my debugging and stuff so much easier because when I'm entering commands like this one here, this port is always different depending on which service I'm hitting up, and that's not going to be the case anymore. I'll always just be hitting up port 8080. Nice. Oh, sorry, whichever port that I'm putting this thing on. I can't remember which port I put it on. 15500. Okay. Let's see. I need to decide which services I'm going to put across. Take me a moment to get all the configurations right, but I guess I'll just do them in order. Pretty much every service at least has a sort of a administrative endpoint. That's going to be an issue, a slight issue. I'll just create a to-do. The issue here is I need to expose manage health through the API aggregator. So each of my services has this manage health endpoint. So you can see an example of that is the entity service. If I go manage/health, you can see that it returns that the status is okay. Now this is mostly used just for checking that instances are in fact up so that Docker can bring up the rest of the state. And once I'm using ELB once I'm using Amazon, it'll be able to spin up new instances if an instance crashes or dies for whatever reason. But it's also nice to have access to these things. We don't have a manage info. So I would like to be able to get at these endpoints via Nginx. It's not critical though, I rarely hit that endpoint up. It will become more important once this stuff is in the actual cloud. So for now, as I keep on saying, I am going to ignore it. UDP RX and TX, I'm just going to skip for now because they have this network mode host, which I am hoping to fix today at the time. And I can't move this stuff across to Nginx while they're using host network mode. Session service can definitely come across. So find the session service, find the config, set the port to 8080. I do need to do a search for that string there. Anytime I refer to that port number, be 8080. I don't think ports.env is meant to be here. No. I don't believe that local env is supposed to be here. This all got replaced with this config.yaml. So let's just get rid of that. The external URL is going to be 155.100. Again here. Session manager URL. No, this is meant to be, this is actually wrong. This is meant to be session colon 8080. I'm going to do the entity service at exactly the same time. That this is meant to be, oh, this is local env. Another local env. Don't want to support them anymore. Just delete them. Okay. Now, I'm not sure how these particular ones are used, unfortunately. I'm not sure if these are meant to be the internal addresses or the external addresses. I mean, we have this directory service, which is this directory configuration, which is clearly meant to be the external endpoints, which makes me think these ones are probably meant to be the internal ones. Services.session. Did I get the answer? I'm not sure, random guy. All I have is 3 messages from you recently. I'm back. I'll give you the answer when I get back and get the answer. I suspect there's a subtle message in there that I didn't understand. Or you've messaged me in another channel, which I'm not checking any other channels at the moment. So I want config.services.session. Services.session is an example. What do we do with this? What do carb-loving zombies eat? Grains? Grains? It's going to be grains. Got that one. Yeah, my money's on grains. All right, so this is the REST clients. Yeah, when we're connecting to a client, sorry, when we're connecting to a service, we need to use this endpoint. So this is indeed meant to be not localhost. This is meant to be session 8080. One is meant to be entity 8080. These become localhost 8080, 8080. Is that right? No, all 3 of these are wrong. These are meant to be 1554 or 15500. I don't think the directory service actually gets used yet. Okay. This stuff shouldn't get used. Dead code. Here's where I find out that I'm still using all the local env stuff. Yeah, you mentioned the using mechanics from Portal 2 yesterday, Random Go. I have to admit, I can't quite remember the um, other than the song. I can't remember the boss fight of Portal 2. This is my entity service. We're going to run on port 8080. This is incorrect. Not even sure how that worked. Entity persist. Ah, there we go. I've exposed that port. It's not correct. Entity persist. This is one hell of a cleanup. Those. Connect directly. That one connect. This is wrong. UDP transmitter should not be exposing its Redis cluster. Connecting on 6379 as a UDP-TX cache. There's no way this is all going to work first go because I'm bound to be breaking things in here. Sorry, blinding people with my background colors. No longer need to expose the port. No longer need to expose the port. '80, likewise, entity service is on port 8080. Okay. Finally, I need to reconfigure Nginx. Two new upstreams. A slightly more logical order. Upstream session. There. Entity. Few more location blocks. Oh, right. Now, this I very much expect to fall over. I'm going to need to take a coffee break in a moment. Just realised. Almost out over here. The odds of this coming up are very, very low. Dating. So far, so good. There's something fail. Oh, no, that was the transmitter service because I've got two instances and they are colliding on their ports. That is surprising. Does the game work? No, I don't think so. Nope, very much not. We have no entities. um, okay. They are. I don't know where that's going to be failing. There are two ways that data can get through to the client. Well, two paths that are required for that data to get through to the client. Got lots of errors down here. It's unable to get session 8080/sessions. Why is that? I don't think I can see. No, I can't see the Docker domain names from here. I probably can if I tell it to hit up a certain IP address. Expose things. Could it be that the session service and or the entity service are spinning up on the wrong ports? No, looks right. We look at the log as it comes up. Hmm. Entity and the session services. Well, is entity is green. up. Entity server started on 8080. Session server started on 8080. Ah, yep, I've got it. The problem here, let me try and demonstrate this. Uh, I connect to, say, the session service. Is that score one? Underscore. So I'm currently running a shell on the session service. Can I run curl? Yes. Entity colon 8080 slash entity entities. You can see that that's actually able to extract data. The problem is happening, so I just need to check a notification. Nothing important. The problem is if I instead connect to UDP transmitter and run that same command, entity colon 8080 slash entities, it fails. And the reason for that is UDP transmitter is running in host network mode. We're back to this old chestnut. All right, now I can fix that by just deleting the network mode of the UDP transmitter, but if I remember correctly, this is going to stop it from being able to send UDP packets. So I need to work out how to allow something in, not sure what the default network mode is, I think it's Swarm or something. I need to work out how to get it be able to send UDP packets from the host, and I need some sort of a port mapping, I guess. Allow this to spin up. Still won't work if I connect the client. In fact, I'm not even going to try. I know that it can't. Well, I will in a second, I guess. Let's. We've got that. All that. There we go. So that's working now. UDP transmitter can now see the entities, which means it can theoretically generate the packets to go out to the client. But when I run it, see that nothing actually happens. And I believe the reason for that is the UDP transmitter's packets are just disappearing. We're getting some errors in here. That's probably saying that sessions are expiring. No. Connection refused. Topology client. Oh, this is even simpler. It can't I've still got something hitting up the session service directly. Makes complete sense. Not, stop. I just kill Unity. Yes, so 15541. This needs to be port 8080. No, 15500. And maybe the thing I just fixed with the network, the thing I just changed with the network mode was not actually the cause of what I was seeing, because if this can't register a session, then there's no way it's going to receive updates. All right. Something else wrong here. Ah, yes. Okay, so the UDP receiver has to talk to the session service, and it currently can't talk to the session service because it's like the transmitter, it's in the wrong network mode. Again, we pull that out. Do need to expose that UDP port. Now, this isn't quite right, and the reason for that is if I have multiple instances of the receiver, they're going to try binding this same port, and this is going to get upset. So what I probably want to do, I believe I can configure Nginx to forward UDP packets. So I should be able to get it to forward the UDP packets onto a cluster of these, which do not expose their ports externally. So let's just try this. Connection refused. I restart this. No, running at all. Won't help. Okay. See that it's established a session. This session will expire at some point because we're not receiving any packets. So it thinks that the server's disappeared or that our connection has somehow gone bad. So after I think it's 60 seconds, it will go and re-establish that session. Down in here, this thing thinks it's all good. It mostly is. I mean, one question I have is whether or not these packets are getting through to the UDP receiver. So I will just quickly check that this code is running. This is where we process the data coming from the client. No, I don't think we're receiving anything here. Oh, here we go. Here to receive a packet from the client. Yep. That's all working. What I want to do next, in this same vein, is I actually want to spin up 2 UDP receivers. To do that, deploy replicas 2. So currently this will fail. All this will fail on startup. One of those servers will have an error. We can get into services, UDP receiver. Got one there that is bound and listening. And the other one here we go. Yep, it's complaining that it can't bind that port. So what I'm going to do is I'm going to pull those out and then into Nginx. I'm going to work out how to set up a UDP forwarder and UDP yeah, this will do. UDP load balancing. Yep, so instead of stream out into a separate window. Think. Yes, that's what I'm after. So this is my HTTP configuration. I also need a stream configuration, which is going to have a stream named UDPRX server. Oh, hey. See, responses close to what I want. UDP receiver never actually responds. And no, I don't think that I can use the proxy responses for that reason. The responses actually come from a different server, which might not be ideal. Maybe I do want to combine those two. services into the one so that I can just get Nginx to do that forwarding for me. Probably easier just to get the UDP transmitter working itself. Okay, so we've got 15540 being listened to. Then need to get window back into IntelliJ. Oh. Docker Compose needs to expose port 15540. I can't remember how to do it. That. Okay, I just saw the UDP receiver come up. It's come up successfully. Check the API service logs. Looks happy. Now when I connect a client, loaded some terrain. We're not getting logs for any of this stuff. That's okay. Spin this up again as a debug. Up or down at the moment. Oh, coming up. Services are all up and bound. This does not seem to be working. See that it's just disestablished a session. That's because it's not heard from it. Okay. I'm going to take 5 minutes, grab myself a coffee, and I will then try and debug this. I'll probably be streaming about another hour today. See if I can remember how to set my little timer here. Here we go. I'll be back in 5. Okay, back again. So, I seem to be having troubles getting these UDP packets to pass through. And I need to find a way of debugging this. Hey, Tunis, how's it going? So what I'm going to do, I'm going to expose another port over here. I don't know, 1555. And I'm going to try using netcat to make sure that the data is making it across to this host. I had some serious troubles with Unity yesterday. I've done an operating system upgrade and a few other things since last running it, and it was extremely unhappy. I just couldn't open projects through Unity Hub, which is very frustrating. It was a large part of my stream yesterday, unfortunately. Okay. So if I restart the rebuild the API service, welcome back, random guy. Uh, Services API. I assume I have to rebuild this. Oh, now we're getting stuff through. Okay, I don't know. What's made to a survival horror game? Hmm. I can't. Yeah, I have no idea, random guy. Sorry, my mind is not in game design space at the moment. I'm very much in back end space in my head at the moment. So is this working now? Something's not working here. That's the UDP transmitter not getting packets out, I think. But all right, let's just do a log.debug. It payload. Yeah, I've had that before, Tunas, where you get kind of strange phantom errors. Okay, what's UDP receiver doing? All right, received processing UDP of 72 bytes. It's coming from UDP receiver 1. Receiver, sorry, UDP receiver 2. UDP receiver 1 doing. I've got a feeling something is not quite right with my Nginx configuration. This really doesn't feel like it should be always hitting up the same receiver, or is it using some sort of sticky configuration? Like if I spin up a new instance over here, it means it'll be coming from a different UDP port. And now we get no messages. Receive failed. Well, proxying and reading from upstream. All right, so the API service is unhappy about something. This error message makes me think that it is failing because it's expecting data to have come back, something. But our UDP receiver never sends data when he ever receives it. Oh, now it magically works. Just going to pour my coffee. So something is definitely not right here with proxying the UDP packets. Yep, now it's gone into another state where it's just not sending stuff through. Ah, it expects one or more responses from the backend. That's not good. I'm going to set proxy responses to be 0. Okay. This has introduced a new slight problem. Which is I have been kind of validating the I've been validating the address of the client using the UDP data. So when we receive a UDP packet from the client, we look at where that came from and store that in their session, and then use that to communicate with them. We then check that the other packets come from that same location. The issue here is that is no longer the case because it's coming from Nginx. We're just going to get arbitrary ports for all that stuff. So this is creating a bit more work than I was hoping, but I will continue down this path because I need the UDP packets to be load balanceable. I don't want to assume that the client will always contact the same UDP receiver. So when the client creates a session, I'm going to need them to tell us who they are. Can't do that. Because a client doesn't necessarily know its own IP address. If it's behind most retail users, their personal PC only has a private IP address. I wonder if we can tell Nginx to spoof the UDP packet. Nginx UDP stream spoof. What's the question? Guidance. Source IP address to the backend server. Oh, this looks easy. I think it's as simple as that. Stop my client because I'm about to break all of the session stuff. Come back to our Nginx configuration and do that. I think that will correctly spoof the UDP addresses. Restart the API service. That is up. Our log messages. Still doesn't look right, does it? Oh, a UDP RX, there we go. We're receiving data. Now my only issue is that it is not properly load balancing. If I just disconnect and reconnect a couple of times, is it smart enough to the RX2? No. Do that a couple of times just in case it's choosing randomly for a given session. I don't think that's going to be the case, but just always seem to be hitting UDP RX2. Still doing it. Is there anything wrong with UDP RX1? Services, UDP RX1. Yes, there's something wrong with UDP RX1. Segmentation fault, that's not good. Something to do with the UDP port being in use. I can stop UDP RX2. Then try starting UDP RX1. Something, bad state. Very unhappy. That's looking better. I don't know what went wrong. One of my containers was just corrupt or something. Debug. Yep, debugger. There we go. Look at this. We're receiving, we've only got one session. But we are receiving data. Okay, something's wrong with our port number. That's okay. We're receiving data through our two UDP receiver services. So that we still have an issue with this here, which is I'd need to know the port. Now, I could get the client to send the port number through its session request, because the client definitely knows its port number. Is that true? No, that's not true. And the reason that's not true is the when a client sends a UDP packet, it's going to go through a NAT gateway, which is probably going to rewrite that port number. So I may not be able to spoof that. is an issue. I was very much hoping to have these UDP packets, UDP servers be transparently load balanced. Ah, yeah, I think I see. I think that I do need to include this. I'll be streaming probably another half an hour to 45 minutes today. Yeah, I a little concerned about this directive, um, but it kind of makes sense. We're asking it to do all sorts of spoofing here. I do intend to stream tomorrow, random guy. Yeah, this makes me a little concerned. Similar time, random guy. So I started today an hour earlier than yesterday, and yes, I'll do probably same time tomorrow that I did today, 10 a.m. Australian Daylight Time. Yeah, I hope this is okay. What I'm trying to do is I'm trying to get it to correctly spoof the port number. You can see the port number is changing in here. Now if we come back in here, wait for everything to stabilize. Received datagram. Port number is still not right. Because the other question is, what's this IP address here? Is this the host address? I'm hoping it's the host address. Fair enough. I need to know the IP address. Docker. That's service API 1. This is underscore. So I think the IP address is correct. And I can probably prove that just by getting rid of those two directives. Restarting API service. So I do have an alternative approach if this doesn't work, which is that the UDP receivers would need to be opened up to the internet rather than coming through this API. And then when you create a new session, the session service would choose a UDP receiver that would be responsible for handling your requests, and then you'd always contact that one. It's not ideal because if a UDP receiver goes down, the client needs to be able to detect that and request a new session. That is already built into my protocol, but it takes like a minute or something for it to come good again. It's tunable, so I could set that to like 5 seconds or something, It's still not ideal. I'd rather the load just get automatically balanced. All right, so let's just see. That still has the same address. And in here, we're receiving packets still coming from the same address. Oh no, they were coming from, I just wasn't at the right spot in the log. So we are correctly spoofing the IP address, but not the port. There is another option as well. It's a bit more work, but instead of using Nginx, I could use like a NAT gateway. And maybe somehow configure it so that even the UDP transmitter could respond. It could respond through the NAT gateway, sorry, and have it automatically route the traffic for me. But yeah, I don't know how to configure NAT to handle those connections coming from multiple hosts within the network. Run this. Close this down. I think we really have a bad session at this point. Okay. This is listening on this port, 56097. It's continuing to just randomly select port numbers. Well, the user root isn't doing what I want, so I'll get rid of that. Over return. Ah, it's not working. Hold on. Save that. Restart the service. Getting an error. No, we're not getting an error. All right. We're going to have to give up on this. The workaround is going to be that the client is going to have to send through the port number that it's registered. Create a session. I need to pull out. It's going to have to send through the client port number. Ah, oh, this isn't going to work though, is it? It's frustrating. do actually have a more general problem here, which is a shame. It means I'm going to have to make a slight change to my protocol. The issue is that we've got the host and the server. Here's our server. Here's our client. When the client sends a packet into here, it sends it with a source port. Now this is fine. If the server were to reply to the client, it would reply by sending it to that destination port, which is fine. The problem is though, we'll generally have in here some sort of a NAT. In that case, what will happen in here is we'll get a source port _1. The NAT will go and put in its own version of source port. It has to be a port that it has available, so it can't make sure that these two are the same. When the server replies, this would all be fine because we're sending it to some UDP port. When the server replies, it's coming from that UDP port. We send it to source port 2. And the NAT sees that and it knows where to send that on the client because it's got a table. The problem we have is this is not actually called server. This is called UDP RX. And then what I have, let's resize this, is I have a UDP TX. And the problem I have is when this gets sent back through here, the actual IP address this is coming from is likely to be different. And therefore, this NAT won't go and do the lookup properly. This is actually a serious issue that I have in my current protocol. Very unfortunate. To fix it, what I'd need to do, the obvious way to fix it would be to actually move these into the same service. And this is easy to do with my current... Oh, what did I just do? Oh, no. There's a bug there. I have to report that one to the author of that. Oops. If I combine those UDP receiver and transmitter into the one service, I still need to be able to spoof the IP addresses. So I'm not sure the best way to handle that. Yeah, this is an issue. Having UDP receiver and transmitter as separate services is going to stuff up anything to do with NAT. the exception to that might actually make sense to do. I could, I don't know why it's just giving me a map up here. Write a service to proxy the UDP traffic. Now, this is probably not terrible. The load balancing would be tricky. So what this would look like is you'd have UDP receivers and UDP transmitters. And they'd sit behind sort of a UDP proxy. It feels kind of like what Nginx is doing. Issue here. Okay, I'm going to have a think about this. I mean, the thing here is UDP receiver is kind of like is kind of lightweight. It doesn't do a huge amount other than parsing the protobuf. UDP transmitter has a lot of load on it. It's constantly comparing game states and things like that. So the benefit of keeping these separate is that they can be scaled independently. With a lot of users, I'll definitely need a lot more UDP transmitters than I will UDP receivers. For things to work properly, I want this proxy to ideally have a single IP address. Even if I have multiple of them, that's fine. A client will just connect to an individual one, which is fine. And it will just maintain a mapping between a session ID and the remote connection details. This is not a complicated system just here. In fact, it's a bit like what the session service is doing at the moment. That's something to keep in mind. Perhaps this actually belongs inside the session service. So once a client connects through its NAT, space here, over here we've got our client. If a client connects through a NAT, this will just forward the data through to the UDP receiver. Might pull out the session ID. That's all it would pull out. That's not stored in protobuf. That's just raw data. So UDP receiver gets it, does its thing. UDP transmitter can know which one of these proxies, I'm just going to call this a proxy for now. It can know which proxy is responsible for a session. Presumably this will update some state somewhere. UDP transmitter can push data into the proxy. Proxy can then send data back to the client. And because this guy has a fixed IP address, this NAT will just work. I'm quite liking this. In the event a proxy dies, one problem we have is that all the clients who are connected to it are going to have to re-establish their session. Not terrible. It's also technically quite difficult to move a client from one proxy to another. Presumably, you could send a packet back to the client saying, hey, I need you to move off this proxy. Can you please establish a new session? And that would allow it to do it smoothly. This is extremely lightweight. It does almost no processing. It just needs to be able to tell. It needs to be able to update the session store or something to tell it that so that the UDP transmitter knows which instance to talk to. That's all fine. I think this is the path I'm going to have to go down. So we should never need many of these. I reckon it could support many thousands of users because it's not doing any processing. Even when it's talking back to the session store, it's not critical, right? If that stuff is slow getting out because it's data that doesn't update often. In fact, the proxy probably doesn't even need to talk to the session store because when the client requests a new session, so let's put in here, we've got the session service. The client requests a new session from in here. At that point, the system could tell the client which proxy it needs to talk to. So that is straightforward. The proxy never needs to talk to anything. If a client, for some reason, were to send stuff to the wrong proxy, presumably because someone was trying to mess with the system, the proxy would forward it to the UDP receiver and the data would just never make it back out. The session would expire after a while. All right. Now, I wish I could implement this proxy in Nginx is the only thing. I'll be ending in just a moment, random guy. Just trying to finish this thought. I mean, I could write this um, in TypeScript. Spam. Thought I had my spam settings turned all the way up. Rid of that. Oh, it's already gone. It made it out to Twitch. Delete Sorry. How is it not possible for me to delete a message in Twitch? Bit annoying. Probably just user error, but yeah, I can't work out how to delete messages. All right. So my two options are implement this in TypeScript. All it has to do is when it receives a UDP packet, it just has to forward that to the UDP receiver. That's really easy. The UDP transmitter would presumably have to... How would that work? It would probably have to call an HTTP endpoint, which is fine. Yeah, I think I'm going to have to implement this myself. I can't see how it would be possible to get Nginx to receive these packets from the UDP transmitter and know to marry them up with the packet that came in and was destined for some other service. So I think I'm probably going to write this off stream. It should be a really simple service. It doesn't need to be tied to the session service. Is there a benefit in tying it to the session service? I don't think so. Maybe. Session service doesn't really do much other than fetch. Fetch details from the that we've previously stored. I'll keep it separate. All right, I'm going to finish up my stream now. I will it's my OBS window. I'll be streaming again same time tomorrow. So until then, catch you all around.